Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Satya Putra. I'm from 28 Senior High School in Jakarta, Indonesia. And in this video, I'm going to explain you more about oils and chemistry. In chemistry, oils have been known as a mixture of hydrocarbon. And hydrocarbon is a compound that only contains hydrogen and carbon. For more details, please take a look at the whiteboard. Here, oil is a mixture of hydrocarbon, and hydrocarbon is a compound that only contains hydrogen and carbon. So please remember that hydrocarbon is a compound that only contains hydrogen and carbon. If you got a hard time to remember what is hydrocarbon is, the easiest name to remember what is hydrocarbon is to remember by its name. So based on the hydrocarbon name, we can get hydro for hydrogen and carbon for carbon itself. So what is hydrocarbon? Hydrocarbon is a compound that only contains hydrogen, and carbon. Okay, let me give an example for you to make you more understand about hydrocarbon. If I have a glucose here, can we say that this glucose is a member of hydrocarbon? The answer is no. Glucose is not a member of hydrocarbon. But why? Here, we can see that glucose have a carbon and it also have an hydrogen. But why glucose is not a member of hydrocarbon? Look, glucose also contains oxygen, but hydrocarbon is only contain hydrogen and carbon. So if glucose contains other than carbon and hydrogen, like oxygen, it's not member of hydrocarbon. So let me repeat it one more time. First, oil is a mixture of hydrocarbon, and hydrocarbon is a compound that only contains hydrogen and carbon. Glucose is not a member of hydrocarbon because glucose contains oxygen, and hydrocarbon only contain hydrogen and carbon. Before we go deeper about oil in chemistry, I want you to look at this video. In that video, you have seen the process of finding oil. And now, I want to show you what is really happening there. Please take a look at the whiteboard. Here, I have the drawing of a landscape where the oil is beneath the Earth's surface. Here, I draw the oil as a black line. The oil usually placed underneath a curved land. This curved land called anticlimate. But how do scientists can know if under this anticlimate there is an oil? The scientists cannot predict it, but scientists can use the wave from the blow of TNT. So the scientists blow this TNT. It explodes and create some wave. From this wave, the scientists will catch the wave by sensors. The sensors will obtain some data about the location of the oil itself. So the TNT blows and there are some waves. The waves reflect and the waves catch by the sensors. And the sensors will give you some data about the location of the oil. This is how scientists find oil. After we get the oil, actually we can use it directly. But why? Please look at the whiteboard. The oil that we got from the earth is basically still a raw. It's a raw material. That's why it's called a crude oil. The crude oil or raw oil then taken to refinery for further process. In refinery, the crude oil taken into a big column. In this big column, a process called fractional distillation happen. The fractional distillation. Fractional distillation use the boiling point law, where the crude oil taken into the column and then heat up, and if the crude oil boil in some point, it will have a different product. Like for example, in here the crude oil is heat up in the column. At 70 degrees, there is a petroleum gases that are already boiled. The petroleum gases is a product from the crude oil, and the petroleum gases can be used for our need. For example, the petroleum gas, usually we use it for cooking or making fire using gases. And then, lower the column goes, it will have a different product, and it will have a higher boiling point. So, if petroleum gases at 70 degrees Celsius, then the petrol will have more than 70 degrees Celsius boiling point. here. So we can say that bigger the molecules, then higher the boiling point. And there is another thing that I want to show, that here the smallest molecules are on the upper side is having a lighter color than the down part of the column. Like here, bitumen have a darker color than petroleum gases. So oil that we use can be used directly because it's still raw. And then the oil taken to refinery for further process called fractional distillation in a big column, whereas using a boiling point law to get its product like petroleum gases that we use for daily use, a petrol that used for car fuel engine, and kerosene that used for plane, diesel, lubricating oil, heavy fuel oil, and bitumen. There are also one more thing that I want to show you, that from this product we can say that bitumen is less used than petroleum gases in our daily life. That's why sometimes the factory that produce bitumen change this bitumen into a smaller size of molecules, which is can be a petroleum gases, petrol, or anything that under that have a boiling point under the bitumen. The process of changing bitumen into smaller size molecules called cracking. Cracking is a process where extract one alkane into alkane and an alkene. Alkane and alkene is a group of hydrocarbon. Okay, I think that's all from me. Thank you for your attention. I hope it will be useful for you, and I think that's all. I'm sorry if there is any mistake in this video. Assalamualaikum warahmatullahi wabarakatuh.